In this video, we're going to talk about electron configurations. You've already had some practice and you've learned how to do it using the Hogg-Hilton, but we need to talk about what the chemistry rules for electron configurations are called. So the first rule is called the Pauli exclusion principle, and what it says is that each orbital, the little hotel room, can hold up to 2 electrons and they have to have opposite spins. So that's the Hogg head up and the Hogg head down. And they can hold up to 2, so it can be empty, it can hold 1 or 2. Make sure when you draw your orbitals for the orbital filling diagram that you draw all of them, even the empty ones. The next one is called the Aufbau Principle. That's a German word. I'm not sure my pronunciation is great, but what it means is that electrons fill the lowest energy orbitals first. So remember that with the ones we did, we started with 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d. And that's the lazy tenant rule. The person or the hogs don't want to go up to the next floor. They don't want to go up to the next floor unless all of the orbitals are filled, unless all of the hotel rooms are filled. If all of the electrons are filled in the subshell, then they move up to the next one. The third one is called Hund's rule, and it says within a sublevel, 1 electron goes in each orbital before you put a second one in each orbital. It's also known as the empty bus seat rule. So think about the first day of school. You get on the bus and there are maybe a half a dozen people on the bus. Do you go sit with somebody if you don't know anyone, or do you sit in an empty seat? My guess is you're going to sit in an empty seat. It's the same way with the electrons. They don't want to share an orbital unless they have to. So you can see in this example on the left, the first 2 orbitals each have 2 electrons and the third one is empty. The way to place 4 is to go 1, 2, 3, and then put 4 with the opposite spin. So make sure that each orbital has at least 1 electron before you put a second one in any of them. So let me show you one more thing, and that's called the diagonal line diagram. And what that is used for is to show the placement of the energy levels. So what you want to do is you want to write these down very neatly and carefully. So 1s goes on the first row, and then right underneath it goes 2s, and then 2p in the same row. And then right underneath 2s put 3s, then 3p, then 3d. Leave a little space between each one of them. And then in the fourth row it's 4s, 4p, 4d, and 4f. And you're going to continue on down with 5s, 5p, 5d, and 5f. Try to keep your columns really straight, it'll help. Then 6s, 6p, 6d, and 6f. And then we're going to go ahead and do our last row, which is 7s, 7p, 7d, and 7f. Okay, so why is it called a diagonal line diagram? It's because you're going to end up making some diagonal lines. So you want to start at the top right and go down and make a diagonal line through each section, and I'll show you. So the first one goes through 1s, and then the next one goes through 2s, then the next one goes through 2p and 3s, and then the next one goes through 3p, 4s, then the next one goes through 3d, 4p, and 5s, and then the next one goes through 4d, 5p, and 6s, and then the next one goes through 4f, 5d, 6p, and 7s. The next one goes through 5f, 6d, and 7p, and that's really as far as we need to go. So what this does is it allows us, instead of you having to memorize the crazy Hog-Hilton order, you can, I'm going to show you the patterns, but this is a way that you can do the electron configurations while you're working on making sure you understand those patterns. So you start here, and so you would fill 1s first. And remember that s subshells hold 2 electrons. And then 2s comes next. And 2s would hold up to 2 electrons. And then 2p and 3s, so 2p, p subshells hold 6 electrons. 3s subshells hold 2. And then we come back up to the next line, and it's 3p and 4s. That was a 2. 3p holds 6. And then there's 4s. It holds 2. And after 4s, we go up to the next line, and we go to 3d. And remember that d subshells hold 10 electrons. And then 4p, which would hold 6, and 5s would hold 2, and so on and so forth. So you just keep filling each of those subshells in order, starting at the top right, and moving down to the lower left. And then you go down, after you've finished that arrow, you go up to the top of the next arrow and follow it down. And you use that to put them in order. You need to understand a couple of things. Something that's important to remember is that s subshells have 1 orbital, which means they hold 2 electrons. P subshells they have 3 orbitals, so they can hold 6 electrons. Remember that each orbital can hold 2. The D subshells, those have 5 orbitals, and I would write this down. So each orbital holds 2, so that gives you a total of 10 electrons. And then F subshells, are you seeing the pattern here? I'm hoping that you guessed that this would be 7 orbitals, and that would hold 14 electrons. Okay? What I want you to really understand, in the next PowerPoint, you'll see the patterns in the periodic table that allow us to understand that. You've done some looking at that, and now we're going to just go over those. So let's do a quick example. Let's try an orbital filling diagram for an element that has 20 electrons. So we know that the first 2 electrons go in 1s. So 1, 2, 1 up, 1 down. Our second ones are going to go in 2s, so 1, 2, so they're a total of 4 electrons now. Then the next electrons are going to go into 2p. Remember to draw all the orbitals. And then it's going to fill them 1, 2, 3, 4, 5, 6. So now we've got 2, 4, 6, 8, 10 for half. So we're halfway there. The next subshell that's going to fill is 3s. And that holds 2 electrons. 1, 2. So we've got a total of 12. Then 3p. So 1, 2, 3, 4, 5, 6. So let's check. 2, 4, 6, 8, 10, 12, 14, 16, 18. We need 2 more. Our next subshell is 4s. And lucky for us, that holds 2 electrons. 1, 2. So that's what you want to do, is when it's an orbital filling diagram, that's the one with the arrows, and you want to draw each subshell with all the orbitals that go in it. If it's an S subshell, it has 1 orbital. If it's a P subshell, 3, and so on. Show all the orbitals, even if they're empty, and then fill it in the right order using Hund's rule, the empty bus seat rule, because you want the electrons to go in the proper order so that it's correct. The last thing I want to show you, we've worked on the orbital diagrams. This is an orbital diagram for oxygen. We know how to figure out how many electrons it has because oxygen has an atomic number of 8. And so if it is a neutral atom, we know that it has 8 protons, which means it also has 8 electrons. So here's the orbital diagram. And then for our electron configuration, remember that what you want to do is you want to take each little subshell, write it down, and then use the number of electrons in all of the orbitals to give it a superscript. So 1s, and it has 2, so 1s2, and then 2s has 2, and in this case 2p has 4. And you continue that all the way through your electron configuration. I will tease you if you say 1s squared, 2s squared. It's 1s2, 2s2, 2p4. If you have questions, see me in class.